Hello, everyone. Hello, let's get the meeting underway. Good evening. My name is Paul Markov. I'll be hosting the meeting as I do most months. Welcome to the April Recreational Astronomy Night meeting of the Toronto Centre RASC. As usual, we have 3 speakers lined up for you this evening. Well, first of all, thank you for coming out on this miserable, rainy evening and on this sports-filled evening as well. We got 4 major games going on in the city. Yeah. Is it 5? The Marlies. Okay, yes, I did forget about that. So getting home might be a little tricky tonight if you're going up or down the DV. Well, up the DVP, I suppose. Anyhow, and hello to folks watching us on YouTube as well. So the speakers for tonight, we'll start with The Sky This Month by Denis, followed by Phil Chow, preparing the CAO for the next 20 years. The CAO is the Carr Astronomical Observatory, which is the Toronto Centre's own observatory on top of Blue Mountain near Collingwood. And lastly, we'll have Tom Otvos, and he's talking to us about thin meniscus mirrors enabling fast, large aperture telescopes. If you use acronyms, please explain what they mean. And before we get started, I wanted to ask if there's anyone here for the First Light seminar, which is taking place next door. Nobody? Okay, very good. So we're all here for the meeting this evening. Okay, so without further ado, I'm going to call on Denis Gray to present The Sky This Month.
All right. Thank you very much, Paul, and welcome sports and astronomy fans to tonight's presentation. This is an interesting thing. I know I haven't been here. I think the last meeting I was able to get to was October, and I made an interesting strategic choice. My son came to me and said, "Dad, I want to try out for select hockey." And I said, "Son, if you can make that team, I'm going to support you all the way." And so I did. And so ever since then, I've been basically helping this boy go to 4 or 5 games a week. And it has pretty well taken care of all of my stargazing this winter. Has been my star here. So anyway, he was participating in 4 different leagues, 4 different championships. First 3, not so good, but the last one here, just this past weekend, he was successful. So he got the championship hat and everything. So anyway, I'm happy for him, and that's a little bit of personal note there. Okay, let's talk some astronomy. So my usual approach to this is to talk a little bit about the big picture, then go into some highlights, see if there's any special events coming up, and talk a bit about some targets, and then I have a special key consideration that I want to bring to everyone's attention tonight. So the big picture. Now this is a chart that I borrow from moonwise.co.uk. They sell calendars and so on. But what I like about this is that it shows the whole night sky going from the evening here, which is the sun setting, Venus in the west, and basically shows you all the things following along the ecliptic here throughout the entire night. So it really gives you a kind of a quick bird's eye view of everything that's coming up. And what we can see here, first of all, is Venus is in the evening sky right now, pretty close to where the sun is right now, so it's difficult to spot, but it's still very bright, so you should be able to pull it out. We've got all of our winter constellations basically diving into the west as fast as they can, and of course we've got the spring constellations here. Right in the middle, and I'll talk about that later, we've got Jupiter. The moon will be full and close to Jupiter in mid-month coming up, and then after midnight, around 2 in the morning, we're going to see Mars and Saturn start to rise. They're in and around Sagittarius right now. And then later on in the night, if you really stay up way late, you can catch Neptune and Mercury. And this is the morning sun coming here. So that's generally what we're looking at for this month. There we go. Oops, next. That's the one I'm looking for. The other thing I always like to think about is where we are in terms of time. So we're not at an equinox or a solstice, we're kind of halfway in between. Right now, today, we've got astronomical twilight, which is the moment when things get really dark and, essentially you can really get busy in terms of astronomy. Everything is fully dark. There's nothing left in the sky in terms of the sun's influence. It's running right now from about 20 after 9 at night through to about 5 in the morning. So our total night length is about 6.5 hours, but we're gaining about 3 minutes of daylight a day. So in just 1 month's time, we're going to have astronomical twilight waiting until almost 11 o'clock before it starts and ending at around 3:30 in the morning, leaving us with about 4.5 hours of true darkness. And I find that this sort of transition from, having a pretty decent long night to having a night that seems like it's almost over before it got started happens very quickly. And of course, June, it's even a little shorter than that, but the transition rate or the rate of change slows down as we get into May and June, as we get close to the upcoming solstice. This is a way of looking at that, which shows you sort of the overall daylight chart for Toronto. So this blue area in the middle is full daylight. Then we've got sort of twilight, civil twilight, nautical twilight, astronomical twilight, and then true night. And you can see here where we are just in the middle of April, late April, how quickly it's changing. And then once we get into June and July, it kind of bottoms out. It doesn't change very rapidly until we get back into September and the nights start to get noticeably longer, faster and faster as we go along there. Okay. Now, one of the things about this time of year is what we're able to look at and what we're able to see is dictated to a great extent by where we are in the galaxy. So I think a lot of you know that we're located roughly about 2/3 of the way out on a spiral arm of the Milky Way. And when we look towards Sagittarius in the summer, we're looking at the center of the galaxy, and that's what this sort of indicates here. This is a galaxy. It's not our own galaxy, of course. I take a few good pictures, but nothing like that. So this is looking towards the center of the Milky Way in the summer. And right now in the spring, we're looking out of the plane of the galaxy, away from all this dust and gas and junk in the middle, which happens to be really beautiful and pretty when you're looking at it, but it does get in the way of seeing things farther away. So a lot of what we think about and what we are looking to observe at this time of year are things outside of the plane of our galaxy. So when we're looking at the plane of our galaxy, if we come back inside and look at what we see, the winter Milky Way, which is this part of the Milky Way that we've been looking at in January and February, the winter Milky Way is setting with the winter constellations, and it's basically on the horizon. And between the fact that the winter Milky Way isn't that bright to start with, and atmospheric extinction, and dust and haze and whatever, you pretty well can't tell that there is a Milky Way on that horizon. So we're looking out of the plane of the galaxy, out towards these spring constellations here, of which the two most sort of notable for most of us are Leo, which has got this triangle butt asterism here, along with a very bright star Regulus, and Virgo, which is a fairly not noticeable constellation other than the very bright star there, and of course Arcturus and Bootes, and we'll talk a little bit about that. So all of this is looking straight up out of the galaxy's plane towards deep space, and that means that it is galaxy season. So looking a little bit closer to home, the planets this month. On April 29th, we kind of hit a milestone that Mercury will be at its greatest western elongation, 27 degrees from the sun. Normally we might get excited about Mercury having a western elongation because it means it's most visible, it's easier to spot, but the viewing angle with the ecliptic right now is pretty poor, so it's not that easy to spot. However, Jupiter on May 9th, which is coming up in just a couple of weeks, will be at opposition. So it's going to be at its very brightest for the year. It'll be fully illuminated, so you'll see all of it. And this is a good time to sort of think about, when you might be able to spot the Great Red Spot. So what I've done here is I've done a table of good moments to see the great red spot when it's predicted to be roughly in the center of Jupiter, all of them sort of around evening time or early, just after midnight, and the ones that are marked in bold are on weekends. So if you are planning to do some star tripping over the next couple of weekends, hoping to get out of town or maybe to set up your telescope, for example, on May 5th, around just before midnight, it should be in a good position. I believe that is a Friday night. So that's something to think about as a potential project. Check out how the great red spot is doing this year. And the big one is Mars is coming. So I think whoever is doing the sky this month, next month, will have more to say about this. But it's reached the point now, 10 degrees width, is it arc seconds we measure width of planets in? Forget that. But essentially, once it gets to about that size, we start to see decent detail on Mars in our telescopes. And what you can see here is, again, looking at this, this is April, this is May 9th, middle of July, and October. And just look at how quickly Mars is going to basically double in size, as we have a very favorable apparition this year when Mars's orbit brings it as close as it comes to Earth, roughly, and Earth happens to be in the right place when Mars is at the closest point. Now, this isn't the best opposition of Mars. That was in 2003, when Mars was as big as the full moon. Everybody remembers that, right? Super Mars. But it's pretty close. It's only, you know, it's that special opposition in 2003 would have, you know, it was one of those kind of pizza effects. Is it an 18-inch pizza or a 19-inch pizza? Can you tell the difference, really? So anyway, I do encourage you to start planning your Mars observing and start to think about it. In terms of where the planets are right now, so Mars is rising at around 2 in the morning right now, and it's setting at around 11 in the morning, and it's at the meridian, which means it's at its, you know, halfway up the sky. It's 6 in the morning. So what that suggests to the intrepid observer is get up early. If you can set your alarm for, say, 5 o'clock and get up early, Mars should be dead easy in the southern sky, and you should be able to see it, and the seeing will be better at that time of year, because one of the unfortunate problems with Mars is when it gets close to us, it also gets low in the sky. So the seeing tends to be poor, which is a good time to go to Chile. But for those of us who can't go to Chile, your next best option is, if you've got a clear night, set your telescope up, put it in the kitchen, pop it out in the morning, see if you can catch Mars early in the morning, and you'll be rewarded with a view that hopefully looks something like one of those. The other thing I should mention is that Martian equinox is coming up on March 23rd. I like to talk about my equinoxes, so I managed to fit one in here. What that means is that the north and southern poles should be equally well lit, so you should be able to do a nice comparison between sort of what's going on in the northern polar cap versus the southern polar cap. And we're expecting the northern polar cap will be still frosty, and the southern polar cap should start to see its polar hood forming, which is when basically the frost from here migrates down there. All right, the other big planet to keep an eye on, of course, is Jupiter. It's rising around 9 o'clock, setting around 7 o'clock, and it's reaching its meridian around 2 in the morning. It'll reach opposition a little bit earlier than that, around May 9th. And again, it's perfect, perfectly good visibility. Saturn is following close behind. It's also a good time. The other planets, not as good, and sometimes almost very difficult. Uranus, for example, I don't think is even feasible at this point in time. The moon, it's always there. I was really pleased to see a nice first quarter over the weekend, nice and high. The moon is roughly now where the sun will be when it reaches its peak in June, July. So we see it nice and high in the sky. First quarter just happened last weekend. Full moon, boo's coming up soon. And then third quarter and the new moon on May 15th, which happens to coincide with the Victoria Day long weekend. So I know that I'm going to be the supervisor up at CAO that weekend, and I know that we'll be talking about exciting stuff in the next presentation. So try to get your reservations in early. I think it'll be a busy time. And then, of course, next lunar eclipse coming up. We're looking forward to that. Some highlights this month. We have our regular Star Party program, and I know Paul will be talking about that. I encourage everybody to take a look regularly at what's going on at rascto.ca/events. We've got a great listing of all kinds of things astronomical. It's probably the best resource, I think, of any astronomy club, and the fact that we cover everybody's action from pretty well Hamilton all the way through to Durham and up to Barrie is great. So do take a look at that. Other highlights. We just missed the Lyrids this past weekend. It was a good meteor event. You may see a few late ones if you were able to get out tonight. Maybe not. But anyway, that was a good one, and the lunar interference is increasing now. So anything that's left over from that shower is pretty well done. There is another shower coming up, which is peaking May 6th, which also happens to be a weekend. So it's the Eta Aquarids. This is a late rising meteor shower. So Aquarius is up late, like really late in the night, like 4 or 5 in the morning. It's going to start to come over the horizon. So you'll start to see some meteors probably well after midnight. But if you're up on that weekend, if you're out and about, you might see some of these coming through. And the interesting thing is that the source comet for these is Halley. So if you're seeing a little bit of Halley's Comet, if you're not going to live long enough to see its next return, this is the next best thing. ISS predictions. I love to put forward great apparitions of the ISS. I did my research and got good news. There's some excellent passes coming up starting May 1st. However, the bad news is you really, really got to be dedicated to see these, because they're pretty well 3 and 4 in the morning, a couple around 4:30, and nothing else that I can see in our planning period. Okay, talk a little bit about targets. So it's galaxy season, and this is that great opportunity that we have for some reasons that are sort of cosmological, I'm sure. In the fall, when we're looking through the plane of the Milky Way towards the other half where we have clear sky, we just don't see quite as many galaxies as we do in the spring. But that's because we're looking at two really large clusters, including the Virgo cluster. And one of the things that you can see here, this is a picture of the Virgo cluster between two bright stars. Denobla is in Bootes. And you can see there's just a whole wacko galaxies here that you can basically see. This is one of those things where you can go through and hit off like 13 Messier objects in a half hour just by following your way through all of these galaxies. Some of the brighter ones are highlighted here, but I would mention that sort of even especially if you're getting started out, even a quote-unquote bright galaxy, it can be difficult to spot, and you do need to have dark skies, and you do need to know exactly where to look, a little bit of averted vision and so forth, and clarity like we had last weekend, really important. Open clusters, there's two really notable good open clusters available in the spring. There's a classic, which is M44, which is an open cluster. It's relatively close to us, and it's kind of in a star-poor area that is halfway between Gemini, the twins, and Arcturus, so it's kind of easy to spot it, especially since it's a big cluster. It's easy to see in binoculars. But nearby, very nearby, is a much more distant open cluster called M67, and it kind of gives you a really good sense of distance and space. M67 is a very similar cluster in terms of its number of stars and its overall size and so on. It just happens to be 4 times further away. So if you can look at the two of them together, that's good. There's another good open cluster, M48, which is in Hydra. It's a good challenge object. You need a good southern horizon to see that, and hopefully we'll get some good skies. Yep, that's the Beehive. That's right. So this, the other set of good targets is some of the globular clusters, and again, we see some of these globular clusters. They're floating all around the galaxy, so when we're looking out of the plane of the galaxy, we can see them, a few more of them. And some of these are really bright and easy to pick up. M3 and M53 are both pretty bright globular clusters. They're kind of overlooked because they're in that season between winter and spring. So we tend to always go for the Hercules, the Great Cluster in Hercules, M13 and M92, and these two are pretty good, and they're also available as well. So I would certainly encourage you to have a look for those. And coming up this summer, there's a promising comet, Right now, this is about 13th magnitude, so nothing really to get excited about, but projected to go up as high as 9th, and it's got some upside potential to it as well. What I really like about it is that it's actually, its path, if you follow through some of these constellations here, this is July 30th, August 4th, so it's going to go through sorry, where am I? No. Oh my goodness, I think I've got my constellations all mixed up. It's going to be good for some other people. I'm sorry. I thought, I've got this mixed up with something. I thought it was actually going right through Cygnus. I saw this Cygnus here, but I just totally misread it. Completely ignore that, everyone. Okay. There are no other good comments to think about. And of course, the big key consideration is clear skies. This is our current weather forecast. It's not looking really promising, except for maybe tomorrow, and possibly Monday, Tuesday next week. Generally, otherwise, not good. Which brings me to sort of the general rule at this time of year. If it's clear, you should really get out there because you never know when it's going to be clear again. So that's all I've got for today. If there's any questions, happy to try and entertain them. Once, twice. All right. Rain, go away. I better.
Thank you so much, Denis. All right, and we're going to move on to our next speaker. You're going to have a pause? Okay. While something's getting updated here on the screen, I forgot to ask, how many are here for the first time? New members or coming for the first time? Show of hands. Welcome. All right. Sean keeps track of the numbers. All right, all set. So here is Phil Chow on the CAO.
Good. Just going to move it back. That's it. Great. Well, thanks everybody. You may have heard a fair bit of chatter on the forum lately about some anniversaries that are happening. I know that the Toronto Centre is celebrating a very big anniversary this year, but also the CAO, which is the EC Carr Astronomical Observatory up in the Blue Mountains, is celebrating its 20th year of operations. And for those that haven't been to the CAO, and I know there's going to be plenty of people that haven't been there because we've got between 800 and 900 members, and I'm pretty sure we haven't seen everybody up there yet. So just to let you know that over the past 20 years that we've been operating that observatory, and by the way, this observatory is actually owned by the Toronto Centre, so it is ours. And outside of our members, it's arguably our most valuable asset that we have within the Toronto Centre. But over the past 20 years, our focus really has been on observational astronomy. In other words, you get your telescopes out there, you have a look at what's up in the heavens, and it's been absolutely wonderful. What we've also noticed is that over the last 5 years or so, there's been a huge shift in our hobby with the advent of better equipment, better software that allows imagers, amateurs like ourselves, to take images of deep sky objects that would rival what the professionals would have done 10 years ago. We're probably exceeding what the professionals have done 10 years ago. And so as we take a look at the CAO for the next 20 years, we realize that we really have to evolve with our hobby. And we're going to be making some significant investments in equipment up at the CAO to sort of bring us into the next 20 years of our hobby. So for those that don't know where it is, here's a map. This is a Google Maps screenshot. We are way down. Where is my mouse? Ah, there we are. We're way down here somewhere, okay? And people remember where the DDO is, the David Dunlap Observatory. The CAO is way up there. It's right at the bottom of Georgian Bay. And you can see that Collingwood is not too far away. It's right over there. The Blue Mountains, that's the town formerly known as Thornbury, is where we are. We are actually located at the top of the Niagara Escarpment. And beautiful skies. It's in sort of a Goldilocks zone for us here in the GTA. It's about a 2-hour drive from most of Toronto, so it's an easy shoot for us to get there on a Friday after work or something like that. But it's far enough north that we've got some wonderful skies. And as we zoom in a little bit more, this is a satellite view through Google Maps, and you can see that's us. This is the Carr Astronomical Observatory. Now, this particular view by Google Maps is oriented perfectly north-south. So we are situated on 51 acres, plus or minus, on top of the escarpment. So we carry, our property is sort of following the 18th side road, goes right about down here, down below the screen where you don't see anymore, and comes back up along over here. This area right along here, it's actually a side trail for the Bruce Trail. So we are right up against the Bruce Trail. To the west is the Beaver Valley, and the Beaver Valley is an absolutely wonderful spot for all sorts of recreation. There's a beautiful river there that you can put in for canoeing and kayaking. The Bruce Trail is all around us. We've got skiing and mountain biking all over the place. In the summertime, this whole area is a mecca for road cycling as well too. So there's lots of recreation that happens along over here. And the fact that the Bruce Trail is actually nearby is relevant, as I'll point out to you later on. We are on farmland, and the space that we occupy for our observatory is just this little area, and the rest of it is all farmland. And so we actually have farming going on our property. It's mostly hay nowadays, though we have had soy grown there in the past, but the soil there isn't really suitable for cash crops. What it really is suitable for is planting telescopes and nurturing the education of astronomy and allied sciences for our members and the public. And so we've spent a lot of time educating our members. We spent a lot of time doing public outreach at the CAO. And so what we're going to do is we're going to do an expansion. Now, to give you an idea of what you're looking at right now, we have certain buildings at the CAO which are aligned perfectly north-south, astronomically north-south, not magnetically, okay? So over here, and I'll show you more pictures of that later on, that's the main observatory, that's the Jeff Brown Observatory. That is perfectly north-south. That is the observing pad, where we can set up our own telescopes on tripods or something like that. That is perfectly east-west. Along here, well, there's Google Maps is a little bit outdated. There you'll see 4 domes over there. These are private observatories. There's a 5th one now, which Denis Gray actually owns, down over here, and there is another roll-off observatory over there. There is another observatory over here. This is the house, and this is the best part of the CAO, because you can stay up until really late at night, and when you're good and tired, you don't have to pack up, you don't have to drive home. Got a 3-bedroom house there. So let's take a little bit of a tour. Going up the driveway of the CAO right now. This is in the fall. This is going back, I think, maybe 3 or 4 years. You can see we just passed a post that's part of our planet walk. We've got the sun at the base of the driveway all the way out to Neptune, because Pluto's not a planet anymore. See the house on the east. We're looking now at the Jeff Brown Observatory. This is our main observatory for our main telescope. And the reason I'm showing you this particular view is that just behind that, to the west of the Jeff Brown Observatory, you'll see this empty platform. We're going to make use of that this year. Inside the Jeff Brown Observatory over here, you'll see this is our main telescope. It's a Celestron SAT 14-inch, a Schmidt-Cassegrain telescope. Piggybacked on top of that is a 4-inch refractor, a teleview refractor. So this roof will retract all the way back. There's also a warm room in there. That's Blake Nancaro walking up to it. If you recognize him, that's our house. And if you come up to the CAO, that's where you'll be spending your evenings and weekends when you're not doing observing. And off to the distance to the north, that's Georgian Bay. So from our deck, you'll have this wonderful view of Georgian Bay as well too. So, what are we going to do this year? Well, inside the Jeff Brown Observatory, we currently have an absolutely wonderful mount. It's a Paramount ME. So it is the top of the line mount for carrying telescopes. It is robotically controlled. On top of that right now is a 14-inch telescope. It's a Schmidt-Cassegrain. I would say that it's probably a little bit past its best before date. The views through that are maybe not as pristine as we would like. And so what we're going to do is we're going to replace it this year with a 16-inch truss tube Ritchie-Chrétien telescope. Now, an RC telescope is predominantly meant for imaging. Instead of the spherical mirror, which you would normally see in a SET, it actually has two hyperbolic mirrors, the primary and the secondary. And what that does is that it takes away a lot of the third-order problems, errors in the optics. And it has absolutely crystal clear views. When you get a telescope of this class, you know you're getting excellent optics. And although an RC or a Ritchie-Chrétien telescope is not normally used for visual observing, trust me, it's fabulous. It has a larger secondary, but the optics are so wonderful that one look through it and you'll be absolutely in awe. It has a focal ratio of f8, which is significantly faster than the existing Schmidt-Cassegrain telescope that we have there. So the focal length of these two telescopes, one being a 14-inch, the other, the new one that we're going to get, being a 16-inch, they're going to be roughly about the same. So we're still going to mount the refractor, which is a Teleview 101 millimeter on top of that. That's used for hydrogen alpha as well as wide field observing. So we do observing in daytime in hydrogen alpha through the Teleview refractor. We also do white light. Currently through the C14, I think we're going to have to figure out what we want to do for white light going forward once we do the replacement. So that should happen sometime this summer. We'll be getting some additional accessories to go along with it. And it will be one heck of a visual system. It can be used for imaging as well too, but our main intent right now is that we're going to use it for visual. One of the things that I'd like to do as well too at CAO this year is I want to train up a lot more of our members on how to drive the system as well too. In the past, if you've visited the Carr Astronomical Observatory, and Denis is going to be one of our supervisors very early on in the season, typically what we do is we have the supervisor in the control room. He is controlling the telescope and he's giving us the play-by-play of what we're looking at in the sky. What I'm hoping that we can do this year is that as our members come up to the CAO, I just don't want to give them the fish, I want to teach them how to fish. And so what I would like to do is get more and more of our members knowledgeable in how to run the system so that the supervisor can actually walk away, because really the supervisors have so many responsibilities when they're up there. They can't afford to be inside that GB all the time. And we're going to let our members take a go at it as well too. It's dead simple once you've been taught. So hopefully we'll get some of that going on this year as well too. We are now going to this year build a dedicated imaging observatory. So as we have the Jeff Brown Observatory right now that we're dedicating for visual astronomy, we're going to build a new observatory on that deck. And it will be dedicated for astrophotography, and it's going to be for the use of our members when they go up there. It will be for use when we have public outreach events as well too. To give you an idea of what it could look like, this picture was taken just this winter, as a matter of fact, by Ian Wheelband. This is actually his observatory on site at the CAO. It is a mini version, if you will, of the Jeff Brown Observatory, so it's a roll-off shed, and we're going to be building something like this onto that observatory. So it's going to be about a 10 by 12. And when it's on the observatory, this is sort of a panorama view taken by Ian this winter of what it looks like from that little deck right now. So we've got almost a 180-degree view over here. So along here, that's east, south is along here, and west is going to be right along over here. So you can see there's lots and lots of sky over there. And the fact that it's right beside the Jeff Brown Observatory isn't going to be a problem whatsoever for the imagers. As most of the serious imagers will say, they don't even want to take a picture of anything below 30 plus degrees above the horizon. I know I've taken stuff at 10 degrees above it just because I'm not very good. But, and I don't know better maybe. But the idea over here is that we're going to be able to book time with our members when they go up there. And as Denis alluded, as we get into the summertime, we don't have a lot of hours of really, truly dark skies for imagers. It can be somewhere between 4.5 to 5.5 hours in the middle of summertime. So we think that we're going to be able to get sort of 2 segments in per night during the summertime. We might get more sort of in the margins of the season. And what we're going to put in there is we're going to put another Paramount mount in there. It's made by Software Bisque. They are arguably one of the leading manufacturers of robotic telescope mounts. This is a Paramount MYT. They call it the Mighty because it's small but it's mighty. Paramount or Software Bisque basically has 3 ranges or 3 levels of mounts depending on how much payload you're carrying and what you need. The Paramount ME, which is what we have in the Jeff Brown Observatory, would be considered top of the line. The MX line is sort of middling, and the Mighty would be sort of at their lower end, but it is significantly better than a lot of the other commercial mounts that are available right now. We will put on top of it an 8-inch Ritchie-Chrétien telescope. So it'll have the same kind of optical design as the new telescope that we're going to be putting into the Jeff Brown Observatory, but 8 inches instead of 16 inches. As well, we will have an 80 millimeter apochromatic refractor on there. It will have a guide scope. It'll have a guide camera. There will be a laptop attached to it. There'll be software preloaded. All you have to do is BYO DSLR, slap it on either one of those telescopes, and you're off to the races. We will give you some very rudimentary instructions on how to use the system, but our expectations are that those that will be booking time on there, we expect them to do a little bit of their own homework as well too, because we won't have the time or the capability with all of our volunteers to sort of provide in-depth training for every single person that wants to use it. So we expect you to do some of your own homework, but we will help you out. So this is pretty exciting because this will be the first time that we've actually had a dedicated imaging observatory at the CAO based on whether or not we can get some more robust internet connection up at the CAO. It might even give us the opportunity to do some remote imaging, but I think that's going to be a few years down the road. Regardless, when we are up there at the CAO, whether it's a weekend when it's being supervised, or even a weekday when we have experienced members up there, we could actually use that system for public outreach here in Toronto. So, for example, if we've got an event going on at the Ontario Science Centre, we could actually have a link to this particular observatory up at the CAO, and we can live stream what that camera is seeing as we go. So I think that's some of the exciting stuff that's going to be happening in terms of adding some imaging capability to the CAO and upgrading our visual astronomy. One of the things that we have to deal with once in a while is that we do a lot of public outreach at the CAO, and that's a good thing. And we've become very well known within the community of the Blue Mountains, within Collingwood and the whole surrounding area. We have lots of people that come up all the time when we have certain open houses and all that sort of thing. The downside is that now everybody knows we're there. And when we're not there, or sometimes when we are there, we get some folks, sometimes teenagers in fast cars, that might decide they want to pay a visit thinking that it's not occupied. And they think that's a great place to get away from mom and dad, or maybe it's a great place to bring your boyfriend or girlfriend or something like that, thinking you've got some privacy. And they come up our driveway and they shine the lights on us and they ruin our night vision because we happen to be there, either doing some visual astronomy or doing some imaging. So what we're going to do this year as well too is we're going to put a gate across the base of our driveway. So it's just going to come along in here. That'll just sort of prevent some of the yahoos from driving up there when we're over there, but it'll also provide us with a little bit more security because it will be a locked gate when we're not physically occupying the site. And this gate over here, that's literally just across the path from us. As a matter of fact, this property previously belonged to Cliff Carr. And the reason our property is called the Carr Astronomical Observatory is because Cliff donated the land and the house to us, to the Toronto Centre. That used to be his property. He has sadly passed away a number of years ago. It's under new ownership, but the idea is that we're going to be putting a gate similar like that in front of our driveway as well too. So it's 20 years now that we've been at the CAO. We're getting ready for our next 20 years, but we're going to have a bit of celebration before that happens. That's going to be going on all summer. So we've got a bunch of stuff going on this year. The first one is in May. It's the weekend just after the May 2-4 weekend. That's our spring work party. On the forum, you will have seen a posting by Laura Chow. She's my boss, also sometimes known as my wife. She's the booking coordinator for the CAO. She's posted that we're now accepting reservations for the spring work party. We're going to hopefully get 20 plus people that will show up, help us. If you show up to work, we'll feed and water you. Your stay over there will be at no charge. And if you think once in a while when you come to these meetings and you get into a room and there might be 60, 70, 80 people and it seems like you never get to really know anybody really well, believe me, you go up to the CAO, you spend a weekend at a work party, and you're working, elbow to elbow, side by side with somebody, you're breaking bread with them, you're having some laughs and some astronomy in the evenings with them, you'll make some fast friends, you'll get to know your fellow members. So, when you get a chance to go to the CAO, it's not just about the astronomy, it's about the fellowship as well too. June 23-24 weekend, we're going to have a rocket building workshop. Hey, rocketry is part of astronomy, right? And Tony Horvatin is going to be leading that workshop. Those that have been to our open houses and awards picnics in the past know that we love our rockets and we're going to shoot up a whole pile of rockets during our open houses. Well, this is a chance for our members, this is a members-only event, to join us at the CAO, learn how to build your own rocket. The weekend is free for you to participate, though you will be asked to pay for the supplies as you build your own rocket. But the idea is that you'll learn how to build your own rockets. You'll be able to test fly it that weekend, assuming that we've got decent weather. And on the July 7th, 8th weekend, we have our awards picnic and our CAO 20 celebrations up at the CAO. So the awards picnic is the Toronto Centre's chance to honor those of our members who have done extraordinary things. And Ralph may be talking a little bit more about that later on, so I'm not going to steal his thunder. But we will be handing out the awards for the Toronto Centre, and we always have a rocket show during the awards picnic. So I'm hoping that those folks that come up and build the rockets in June will come up again in July, bring the rockets. We're going to have a whole lot of fun. August 18th, that's a Saturday, we are going to have, for the first time, a joint Beaver Valley Bruce Trail Association and Toronto Centre hike, potluck dinner, and astronomy day. I'd mentioned to you that the Bruce Trail goes right past our property. It's the Margaret Paul Side Trail. And there's a dedicated group of volunteers with the Bruce Trail Association. They're part of the Beaver Valley group that spend time maintaining the trails, making sure it stays clean, removing any debris and all that sort of stuff. So they're a group of volunteers just like ourselves. I kind of like to think that they're also kindred spirits because, you know, we as amateur astronomers, we have a great respect for the environment. We have a great respect for the flora and fauna. And I believe that the Bruce Trail folks, you know, are of the same mind. The idea for that weekend is they've got a whole pile of members that are really interested in astronomy, and it's a wonderful chance for us to do some outreach with them. So they're going to take us on a guided hike first during the day. There's a long hike and a short hike, depending on what you want to do. And of course, you know, what better than to have experts of these trails show us around. We're going to have a potluck dinner together, and then we're going to give them a dog and pony show on astronomy as well, too. So, you know, they're going to do something for us. We're going to do something for them. It's also a fundraiser for both organizations. So we plan on charging $15 a head for those that want to participate in this program. And the idea is that we're going to split the proceeds 50-50 between ourselves and the Beaver Valley Bruce Trail Association to support both our outreach programs. September weekend, 7th and 8th, we're going to hold the Astrophotography Workshop Part 2. 2 years ago, we actually held Part 1 up at the CAO, and that was for folks that had never been exposed or were very, very new to astrophotography. This was photography, you know, with your DSLR on a tripod, stationary tripod, or maybe on one of those smaller tracking mounts. Part 2 will be imaging through a telescope. And so we're going to be posting that event probably in another couple of months or something like that. We're just organizing the logistics for that now. There will be some prerequisites for people that want to participate in it. But certainly, I think that we may actually have a bit of a sidebar workshop for those that are absolutely brand new, and we might take them aside, may give them a quickie course on Part 1 or something like that as well too. But sort of stay tuned for those particular details. We don't have that all fleshed out just yet. And finally, in October, we're going to have our fall work party as well too. So the work parties are in the spring. It's sort of like opening up your cottage. In the fall, it's sort of closing it down. The site is open, 365. So it never closes, but we only supervise or, sort of manage it during the observing season, which is, we'll call it 3 seasons out of the 4, if you will. In the wintertime, because the access to the Carr Observatory, the road access is not plowed by the town, you can't drive there. It's one of those you can't get there from here. So you've got to park a little distance away, then you've got to snowshoe in. You got to probably drag or carry your stuff into the house on a sled or something like that. So access is a little bit more challenging in the wintertime, but if you're up to the challenge, it is open all year round. We only close for a few special events, in particular when we have scouts there, because they would be considered a youth group, and we don't want anyone there that doesn't have their appropriate police checks and all that sort of stuff. But other than that, generally speaking, it's open for our members year-round. So that's what we've got planned for the CAO this year. I just did want to give some credit to the people that provided me with some images. The drone video was done by Michael Story. This was done a few years ago, and Dietmar, who is sitting in our audience right now, he's kind of done all the video editing. This background, this image right here that I've been using as a background, that was done by Katrina in Slum. This was taken during the spring work party in 2013. This is a view westward just after sunset, which is why you're getting this lovely orange glow. These 3 points of light are the three-planet conjunction. You've got Jupiter, Mercury, and Venus over there. And obviously, I've taken great liberties with Google Maps. And that's it. Any questions?
Hello, Phil. You mentioned Bob German here. You mentioned the gate that is going to be installed in order to prevent access from what you call the Yahoos. How are we who are non-Yahoo going on a routine basis to access this? Are we giving a key or being an accommodation or what?
Yeah, just like if you were to go up to the CO anytime right now, if you're going during a weekend when we actually have an on-site supervisor, the gate will be left open for our members. If you want to go up during a weekday when it is not supervised by one of our staff, unpaid staff, they're all volunteers, by the way, the process right now is you get a key, you get a passcode, and the gate will actually have a padlock on it with a passcode on it as well, too, and you'll be given that as well, too. And just like with all the passcodes that we have for the house, as well as for the gate, it'll be, that passcode will be changed on a regular basis. You're welcome, Bob. Any other questions? Charlene?
Just wondering what you're going to do with the 14-inch.
We will likely sell it unless you want it. No, the 14-inch has served us well for quite some time. We find that the views through that 14-inch are a little bit soft. The primary mirror does have a flaw on it. At the very edge, there's a bit of a crack on the very edge. Theoretically, it shouldn't really have a major impact on the views through that telescope. But generally speaking, I think we've got a Friday or a Monday scope. Ed?
Do you want to talk now about any of the changes to the site?
That's been well posted on both the website. It's posted when you first go online to book, and it's been posted on the forum as well too. So no, I don't think I really want to spend a lot of time with that right now. Any other questions?
Any chance the Recreational scope will be ready for Mars opposition?
Maybe. Maybe. I don't have an update in terms of the delivery. So, Ron, the actual installation of the RC is quite simple. It's literally just demounting the existing C14, slapping the RC on, and you're good to go. Except that we want to do some improvements in the wiring. So, the wiring, which comes from the warm room, goes under the floor of the GBO, and it goes up through the mount. It's a bit of a dog's breakfast right now. It's got cables in there that are now obsolete, that don't go anywhere. It's got styles of cables, serial cables and all sorts of weird things, that really just aren't used a whole lot by modern equipment. So we want to do a bit of a cleanup on all that wiring, so that's going to take a bit of time. Theoretically, a couple weekends, Dietmar, and we should get that done. So it's a matter of when we can get the delivery, and it'll be ready to go. We don't anticipate that the scope or that observatory will be out of commission for any length of time. Bob?
She's embarrassed. She doesn't want to appear to be a troublemaker. I quote you, Tessie. There was mention made some little while ago of a hole in the road leading in, and the municipality has to take some responsibility for that. Has that been addressed?
Yeah, what happens is that the town does regrade the surface of the roadway, typically a couple times a year. And typically after winter, when we've got a lot of spring runoff, it creates a whole lot of ruts in the road. So if you've got a low-slung car, you might have a few problems getting through. If you had a 4x4, it shouldn't be a problem. When the snow finally melts, and it hasn't all melted yet, Bob, and Tessie. It hasn't all melted yet, but once it does, typically we give a call to the town and ask them to come by with their grader, and they're pretty good about that sort of thing. You're welcome.
Question?
Sure, Paul.
The Google satellite map has a very nice icon. It says Carr Astronomical Observatory. It's almost like they know about us.
They do know about us, as a matter of fact. We used to be one of those great secrets that we didn't want everybody to know where we are, because we weren't there very often. You know, we were there on weekends, and it was sort of left unoccupied during the weekdays. That really doesn't happen as much anymore, because you know, we've got so many members that are interested in going up there during the weekdays that it's occupied a lot of the time. And we do so much more public outreach that we're pretty well known. So if you actually Google or search Carr Astronomical Observatory in Google Maps, it pops up.
The question online, I believe, is when did you say the new scope is being installed?
It'll be this summer. Yeah. Yeah. We anticipate it'll be there before our open house. Sorry, the question was, when do we believe the new scope will be installed? It'll be, the open house is in July, and it'll be nip and tuck. Yeah. In June is when we expect to do the bulk of our construction for the imaging observatory. But that's a longer term project. It will be done this year, but it's most likely going to be fall before the imaging observatory is going to be done. In terms of the 16-inch RC, Dietmar, do you have any further updates on the timing of that? Oh, I didn't like the sound of that. Okay. This year. Yes, Paul.
The air conditioning unit getting installed.
Bring a fan. No, we don't have air conditioning. We'll just open a couple of windows. We actually don't need air conditioning, by the way, inside the CAO.
What's the brand of the scope?
It's a GSO, Serge. Guangchong Optical. Yeah, so Guangchong Optical is a Chinese manufacturer. They're also the same people that do Skywatcher. Celestron isn't owned by, Skywatcher is owned by Guangchong. So it's the same company. Yeah. Sorry, yeah, GSO is Taiwanese, Cinta is mainland China. It's GSO in Taiwan. Anything else? Okay, thank you.
Down. Getting ready here. Let's see. Tom Otvos. Am I saying it right?
Otvos.
Otvos. Very good. So he's talking to us about thin meniscus mirrors enabling fast, large aperture telescopes.
Oh. Good. Okay. Still sticking up? There we go. How's that?
Jeez, that is hard.
Yeah. How come I'm the only one that has the problem? I have high ears. There we go. Okay.
Sign of intelligence.
Yeah. Okay. Lights, camera. Awesome. Okay. My name's Tom Otvos, and tonight I'm going to talk to you about thin meniscus mirrors and how they're a new technology that's enabling
fast, large aperture telescopes. Just by way of background, oh, sorry, and it's 3-2 for Boston right now. Like Denis, I have kids in hockey. I have 2 boys in hockey. I'm a coach on one of their teams, and hockey just ended last weekend for us as well. So just by way of background, a very quickie, I'm a long time but new member of RASC. I was a member back in high school, university days of the Toronto Centre, and then life just sort of got in the way, and I dropped astronomy for a considerable period of time, and then just recently have gotten back into it. I'm a member of the Mississauga Centre and an affiliate here in Toronto. And, you know, along the way, I had a Dobsonian that, you know, that I just kind of, up at the cottage, you know, a nice weekend, I'd be using it. But I wasn't really actively engaged in it until a couple of years ago when I came across these thin meniscus mirrors, and I'll be showing more pictures later. But that really kind of re-energized my interest in the hobby, and specifically not just the observational part of it, but the actual fabrication of it. I don't know how many ATMs are actually in the audience. I saw some people come in, Frank and Norm were there. So there are a few ATMs in the audience, and so and some of them actually know, you know, what I'm doing. But basically, this is all about fabricating mirrors that are that can go into large aperture scopes that are highly portable. So that's the general gist of this. So what problems are we trying to solve when we're talking about meniscus mirrors? Well, basically, when you have a large aperture telescope, they're difficult and expensive to fabricate if you're fabricating them. If you're buying them, obviously they're very expensive, and typically that's because and one of the impacts of the large mirror, a traditional large mirror, is that it has a lot of mass. And as a result, the telescopes themselves take a long time to cool down. And if you have a very heavy mirror, you need a big beefy support, you know, which is why, you know, with the Carr, you've got a 16-inch, but you need like a really big support. So one of the things that we're trying to solve is how do you make large aperture mirrors much more portable? Typically, focal ratios on amateur scopes rarely go below f4.5, and for the Carr, we're talking about, you know, an f8. Presumably, the 14-inch was an f10, I guess. So much larger focal ratios, and when you combine a large focal ratio with a big aperture, you end up with a big honkin' telescope. You know, and if you're looking at apertures, say 24, 30 inches, that kind of thing, you're talking about ladder access only. You know, so again, that's a problem that we're trying to actively solve. So this is the question: how do you make a compact, large aperture scope cheaply? Who would be interested in something like this? Well, there's amateurs who are always, you know, who have aperture fever, and they are always looking for that bigger and bigger light bucket to get those faint, fuzzy, deep sky objects, or to do, you know, wide field astrophotography, or even just photometry. You know, there are people who are not really interested in actual, you know, fine detail, but to do photometric measurements. University astronomy departments who don't have ready access to a major observatory, they could definitely use larger aperture scopes for their research and for teaching their students. Citizen scientists, a lot of people in this audience who are interested in doing real science. And so fortunately, I've gotten myself involved with a group called the ALTAS Initiative. And this was a group that was started out by a bunch of amateurs out in Oregon, of all places. Basically, they've sort of mandated themselves as trying to make 1 meter class research-grade telescopes easily obtainable. And so that's their goal, and they've got a number of different groups of people that are researching different areas to try and make that goal happen. So one of the ways of creating large aperture telescopes and solving some of these problems is to use what's called a thin meniscus. And does everyone know what a meniscus is? Basically, think of a contact lens. Okay, so traditionally, your telescope mirror, looks like this. You have a really thick slab with a very gentle curve polished into it. And for, let's say, a 25-inch mirror, typically this is going to be 2 inches thick. And so if you just do the math, you end up with 100 pounds of glass. That's just the primary itself. And then you've got all of the other stuff. And because the focal length here, let's say this is going to be, an f5 or an f6, you're talking about many inches of telescope length. So you're talking about a big honking telescope. Contrast that with a meniscus, which is pictured here. This is a 25-inch meniscus created by someone called Mel Bartels, who's really one of the vanguards of this whole thrust of using thin meniscus mirrors, and he's one of my mentors and helping me out. So this is his 25-inch, which he recently actually completed. It just came back from the silvering or the alumnizing, and you can see here it's 25 inches in diameter and it's 1/2 of an inch thick. And so if you just do the math, this is 20 pounds of glass. So this is 1/5 the size of this mirror. So just from a sheer weight perspective, this is like hands down going to be far more portable than your traditional glass. If you consider focal ratio and how this impacts things as well, this table here lists a couple of common focal lengths, focal ratios, and the corresponding sagitta for a 14-inch, which is my personal project, and Mel's 25-inch. The sagitta is the distance, is basically the depth of the curve of your glass. So basically, it measures from the edge down to the deepest point. And so you can see how the faster your telescope, the deeper your sag is in your glass. And so for a 25-inch, the sag here is 6/10 of an inch. So at f2.6, if your typical blank is going to be 1 inch for a 14-inch mirror or 2 inches for a 25-inch mirror, you're looking at about 1/3 of the thickness of your blank is going to be carved away by the curve. What that means is that if you've got 100 pounds of glass and 1/3 of it in the center has been carved out, that leaves 2/3 there. So it's going to totally mess up the thermal properties of that glass, as well as structurally. You're basically making it considerably weaker there. So all of these things kind of compound. So if you're looking at a large aperture, you can't actually fabricate a fast mirror without having a whole bunch of other complications. For a meniscus, however, again, think contact lens, basically the thickness is the same for the entire length of the curve. So basically the mirror is curved front and back so that it's of uniform thickness. That means that, for one thing, it's going to reach thermal equilibrium much more evenly. Secondly, because it's only 1/2 inch thick as opposed to 2 inches thick, it's going to reach thermal equilibrium much more quickly. And then it turns out in practice that because of the curvature, it's inherently stiffer. If you think about a piece of paper that just kind of flops around, but then if you kind of fold it into a cone, it just has more inherent stiffness to it. So the curvature actually serves to make the overall mirror much more stiff, so that a 25-inch, 1/2 inch thick piece of glass, it doesn't show any sort of astigmatism when it's actually mounted, which is a very important thing. Now, meniscus mirrors aren't the only way to solve the problems that I was talking about initially. There are many other alternatives. Another way of reducing just the weight of large mirrors is to do what's called honeycomb casting, where basically the bulk of the mirror is open airspace, and they cast it in special molds. And so, for example, the Giant Magellan Telescope uses this approach, and lots of large telescopes use this. Spin casting is another approach that's being actively researched by one of the members of the ALTAZ initiative. And basically what they do is they get a liquid epoxy and then they slowly spin it on a turntable. And that naturally creates a parabolic shape on the surface. And the trick here is how do you create an epoxy resin that as it hardens doesn't actually change the shape. But that's what they're actively doing research in. And then once they've got that thing hardened, then they would basically coat it. and presto bingo, you have a mirror. Foam glass is another material that's been explored, which is basically, it's like foamy glass. You know, it's a very, very lightweight material, and they use it, and it's very easily formed. Obviously, it's not very rigid, so it's got its own problems. All of these things are other talks, and you know, they're all interesting areas of research, but that's not really what I'm about here. So what I'm about is meniscus mirrors. And once I got into this and started exploring this, I thought, well, hey, how hard can it be? So I wanted to tackle the project. And after seeing some of Mel's telescopes, I've got a picture of one at the end, I was just like, okay, I absolutely have to have this. Because one of my problems was I had this big 8-inch Dob, and it wasn't portable at all. So basically, it was up in my cottage all the time. So it was only accessible when I was at the cottage, which meant almost never in the winter time. So, you know, hauling it back and forth, pain in the ass, right? So I wanted something that was highly portable. But I also had aperture fever. It was only an 8-inch, and I wanted a much larger scope. And I'd been, you know, saving my pennies for, you know, like a Meade 16-inch, something like that. But I mean, that's like serious dollars. So this seemed to be an approachable way of giving me a large aperture telescope in a highly portable form factor. So how does one go about making a meniscus? Well, basically, digital kiln controllers are the key enabling technology to this. And what they allow you to do is allow you to provide a very, very strict temperature control program for a kiln that then allows you to slump glass into your meniscus shape. And the kiln is just a commodity item in this case. It could be any sort of, you know, pottery kiln, ceramic kiln. The one that you're seeing here, so this basically this silver thing is the kiln, and here's the kiln controller. And this I got off of Kijiji for $100. So it like totally commodity item, and all of the magic is in this box here. While the kilns are a commodity item, form factor is a bit of an issue. Like, for example, this thing here is 17 inches in diameter. So what that means is that the most I can slump is a 16-inch mirror. And there's a ton of wasted space in here because this is, you know, this is intended for large pieces of pottery. So, you know, when you're using ceramic kilns, you have to kind of shop around and try and find what what will work for you. But really, all of the magic is in this box. This is a close-up of the box itself. This thing here in the center is just basically it's a PID, PI. Can't think of what the PI stands for now, but basically this is like a little microcontroller, and it allows you to program it. And these things over here on the left and the right are solid-state relays, which are basically controlled by the PID. So the PID just basically switches these relays on and off, and the main power going into the kiln elements are controlled by these SSRs. So essentially what you're doing is you're switching the kiln on and off, on and off, on and off, and there's a thermocouple attached to it as well that measures the temperature to a high degree of accuracy, and you just basically program it to say, you know, here's my temperature curve that I want over a period of time, and it just measures the temperature and turns the kiln on and off, and you get your slump. Now, slumping glass, so there are really 4 major steps here to actually making this happen. So the first thing is you need to create a mold. And what that mold is going to be inside the kiln, you're going to be placing a form that is going to be supporting the glass, and the glass is going to melt onto the form. To create that form, you need to create a mold, which is basically the negative of the form, which is going to have the initial shape that you want your glass to conform to. So typically what you do is you use plaster of Paris, and you just create a blank out of plaster of Paris, and you use normal ATM hogging techniques to just kind of make the shape of the glass that you ultimately want to end up with. And so you'll have it in your head, you know, that I want a 14-inch f2.6 mirror, which is currently what my project is. So that will imply a certain curvature, and you carve that into the plaster of Paris. Once you have that, you basically use that as a form as a mold for the form that is going to go into the kiln. Now this form is, the trick here is that this thing has to be made of a material that's going to be able to withstand the temperatures of a kiln. And when we're slumping glass, we're talking about 600 centigrade, 650 centigrade. So you need special materials, and it's a secret recipe, but it turns out that the recipe is refractory cement and perlite. Now, and you don't even have to use refractory cement. You can just use we've experimented with different grouts. Basically, what you want is something that doesn't change shape as it sets, so that once you put it into your form, it's gonna faithfully reproduce the curve that you've carved into your plaster of Paris. But then you also need it to be able to withstand the kiln temperatures. The problem with just regular grout, non-shrinking grout, is that it doesn't withstand kiln temperatures. And so what you do is you introduce this perlite, which you can just get at garden centers, and perlite is a super insulator. And so what you do is you mix the perlite with the grout, and you just have the grout, just enough grout to hold the perlite into shape. And you make this goopy stuff up, and you press it into your form, and once it sets, you have something that's going to be kiln ready. I've done this several times now, and lately I've been actually using refractory cement. Refractory cement is basically cement that is intended to withstand kiln high temperatures. It's typically used for furnace repair, that kind of thing, or fireplace repair. But you still put the perlite in, because if you just cast a solid slab of cement, really, really heavy, very unwieldy. So the perlite, among other things, makes it super light. So you end up with a big form, but it's really, really light because the vast majority of it is perlite. Once you have this thing created, you put it into the kiln and you run it up to temperature to make sure that that it all stays together, that you didn't screw up somehow. One of the runs that I did, and I don't know why it happened, but when it came out of the kiln, instead of at that time I was still thinking I was going to do an f2.8. But when it came out of the kiln, my form was actually an f1.9. So that went into the garbage. But several tries later, I got something that, that actually held the curve, and so I was good to go. Then the last step basically is actually putting the glass onto the form, into the kiln, and programming the slumping cycle. And here, the slumping cycle, we're talking about 48 plus hours. So, for 48 hours, this thing's humming away in your garage or wherever you've got your kiln. And don't lift the lid, because you might scream. So it's a real exercise in patience waiting for this thing to complete. This is what my form looks like. It's actually quite smooth. It's surprisingly smooth, but you can still see little pock marks here. And you don't have to worry about those, because when you, just prior to putting it into the kiln and putting the glass on top, you use what's called ceramic talc, which is a super, super fine thing. It looks like baby powder. It looks like gray baby powder. And you basically spread it all over the surface, and it fills all of the little voids. And the idea is to make a super, a nice smooth surface on the form, and then you just place your glass blank on top. One of the things I didn't mention is that all of this work, it doesn't use exotic glass at all. Ordinarily, for telescope mirrors, you're talking about Pyrex or whatever, but because they're so thin and because they reach thermal equilibrium so quickly, we've been using plate glass. So just really dumb glass that you can get from, a place where you get glass tabletops or whatever, and they work perfectly fine. So you place your plate glass on top of your form and put it into the oven and bake it. When it comes out, it looks something like this. Anyone that's doing these Meniscus mirrors, this is the trophy picture. Everyone seems to be taking the same shot. You've got the Meniscus there. You've got a bar with the digital gauge or the gauge measuring the sag on it. But you can see here, so there's a slight sag in this glass, and also there's a corresponding sag on the back side too. So basically, when it comes out, it looks literally like a contact lens. Now, that's how you make a meniscus. But if we rewind all the way back to the beginning, you know, one of the goals here is to not just make meniscus mirrors for the weight aspect of it, but also to make fast mirrors, because we also want to have large apertures in a highly portable form factor. So the meniscus allows for the constant glass thickness, and that's independent of focal ratio. But if we're talking about fast meniscuses, it's still a fast mirror, and it's really, really difficult to fabricate. So typically, you know, when you're making a mirror on your own, you start by creating a spherical shape, and then you parabolize it. And the delta in going from the spherical mirror to the parabola is usually measured in the number of waves of light, waves of green light. And typically the correction that you have to put into a sphere to make it parabolic is usually less than 10 waves for a typical ATM mirror. And if you're over, say, f15, you typically just work with a spherical mirror. You don't put any correction in at all. My f2.6 requires 39 waves of correction, and the 25-inch of Mel Bartel's has 63 waves of correction. So that's a lot of correction, a lot of manual polishing of this area, but not that area, to get just the right shape. It's a really, really difficult thing to do. Much more difficult. You know, when I mentioned that I was going to be doing this to a couple of the guys, they're going, "Oh, at a 2.6, that's going to be pretty challenging." But I've seen people do it, I know that people do it, and so that means it is doable. It is difficult. The measurement tool of choice for this type of thing turns out to be the Ronchi test and not the Foucault test. Typically, ATMers use Foucault test. I mean, and sorry, when I say typically, I mean as up until relatively recently, when there are actually a number of really, really good alternative tests. But historically, the Foucault test was sort of the ATM tool of choice. But the Ronchi test is a much more appropriate test to use for this, because of the fact that the Foucault, because the curves are so steep, it's really, really difficult to get accurate Foucault measurements. And the Ronchi is a very, very intuitive and easy test to set up. So here's sort of an example of the two approaches here. So this is a Ronchi image. The dark lines are the actual what you see when you do the Ronchi test, and the red lines are the theoretical predictions. So basically, what you do is you look at your theoretical prediction. You look at your theoretical prediction, and you compare it to what you're actually seeing, and that will basically guide where you need to polish to get the figure that you need. Foucault, on the other hand, I guess I should have been doing this. So while you can't quantify your errors, you can certainly see where your errors are. So you can see here, you know, the curve here is not quite deep enough, and this is too sharp here. So these are the sort of the qualitative things that you get from looking at this test. Conversely, the Foucault, which is normally something that you would actually do measurements on, is difficult to do for the fast mirrors. However, you can still use it as a qualitative tool to assess your general surface shape. And so, you know, this should be spherical, this should be all uniformly shaded, and you can see there's actually some pretty grody roughness here. So it's good for doing kind of smoothness tests. Ultimately, however, you know, you do the Ronchi test for as long as you can. Ultimately, though, the final arbiter of how good your thing is to put it to the star test. And the star test allows you to really assess, you know, the level of doneness. Now, this is my star test rig that I built for my mirror. And the cool thing is, this distance from here to here is only 27 inches. So this is a 14-inch mirror, and it's basically, you know, this big. So, really cool. Here's more examples of the Ronchi test versus the star test. So this is the current status of my mirror here. And you can see that it actually is doing really, really well as compared to theory. Although, you know, for example, here you can see that it's actually dipping this way a little bit. And in here it's curving a little bit in. And at the edges, it's not curving quite enough. So you can see that it looks close, but not perfect. And so this is the point where you say, okay, so what do I do next? Well, what you do is you star test. And the star test, so here's a star test result from this mirror here. And while the star test, you need to actually take several views and see how it transitions and all of that. So a static image isn't a good here is the answer kind of thing. But you can see, for example, this bright line here should not be there, and this bright line probably corresponds to this defect in here. So doing the star test basically will give you the final word on whether this is a good thing or a bad thing. And I should have been clicking. This here, the fact that I have a nice bright ring around the edge is a good thing from a star test perspective, suggesting that my edge is actually pretty good. But this ring here is suggestive of this flatness in here. Absolutely. Yes. Oh, no, absolutely. Yeah, the lines are there. Basically, the lines, if it's a sphere, then your lines are going to be perfectly jail bar straight. And as it becomes more and more parabolic, the lines curve more and more. And the other thing is that as you get closer and further to the radius of curvature, you get more and more lines. So basically, your goal is to find a spot outside of your radius of curvature where you get a handful of lines, so not just one or two, but like 5 or 6, and they have some good curvature to them, so that you can then look at them and empirically say, okay, well, this is good, this is bad. So the lines are always there, absolutely, and the curvature, the theoretical curves, which are these tan lines here, you can very readily predict them, and so they're, for example, Mel Bartel's on his website, he's got a Ronchi calculator, and you basically input your parameters of your mirror. You say, okay, 14 inches, focal length of this, blah blah blah, and then boom, it gives you your theoretical prediction. And then what you do is you take the test, you take the photograph, you overlay the image, and then you can do these sort of assessments. This was what got me down this odyssey here. So this is Mel's 13-inch. So right now he just is completing his 25-inch, but prior to that he did a 13-inch. And when I saw this, I thought, oh man, this is just so cool. This would be so cool at the cottage. I can just put it in my trunk. One of the neat things about this is the way it folds up. It just kind of clamshells. Is that cool or what? That is just so cool. But again, this is a 13-inch, and this is an f3, so a 39-inch focal length, but still very, very portable. Now, so that's sort of the end of my talk. Just one sort of sharing moment here. This is actually version 2 of my mirror. This star test rig here was missing a very important piece, and that is a clip that will prevent the glass from tipping out. And so this picture was taken last summer, and I was really, really close to being done. And obviously I was doing star testing, and I had some crappy weather, so I was trying to do some star testing with some faraway lights, and I wasn't paying attention, and I tipped it too far, and the glass tipped out. So the mirror that I'm working on right now is version 2. However, cool facts. The first mirror, to get to from where I started to tipping on the driveway and breaking into 2, was about 19 months. After about a month of, oh my God, what am I going to do? And I decided that I'm going to continue on. The approach that I decided to do was, because it actually almost literally broke in 2. There were a couple of other shards, but it was largely in 2 pieces. I used windshield glue to glue them back together, and while it would obviously not be optically perfect, it was good enough for me to then cast a new kiln mold, and then from there to cast a new form. So basically, this broke in August. By September, I was slumping again, and by January, I was in the final stages of my figuring. And so in the last couple of months have been really, really slow progress with doing this fine-tuning of the figuring. But, a 19-month project, has sort of been compressed into a 6-month. So you definitely learn, from your mistakes. And yes, the test rig does now have a tip clip on it. Yeah, so I'm at star testing now, and hopefully this will be done by the summer. So that's all I have. Does anyone else have questions related to this? Frank? I am definitely able to do something for people if they want to, and and I mean I could even build the molds, but ideally you guys could do that. But yes, I am available to do kiln runs for sure. Norm.
Hi Tom. How do you measure your initial radius of curvature so that you can do your offsets for your Ronchi gratings to get the patterns that you presented,
right,
versus the pattern that is predicted by Mel Bartle's calculator?
Right. Well, it's an iterative thing basically, and so once you get to a spherical curve, because you'll be able to do tests to determine that it's spherical. And then once you get a good sphere, it's just an issue of moving it back and forth until you get a decent focus of your test LED on your tester, and that's good enough, at least for the initial stages. Because if you use the calculator and then you actually perturb your radius of curvature, you'll find that the predicted things don't change very much at all. So even if you're off by like a half an inch, which is pretty big, you will hardly see any difference in the Ronchi images. And then as you're iteratively going back and forth, you narrow your radius of curvature down until you're, within, 1/16 of an inch or whatever.
I have a series of questions, actually. Why would you want to do this first?
Well, so I'm an engineer, and so I like the hands-on aspect of it. Number one. Number two, as I said, before, I had this large Daub, and it wasn't highly portable, and I wanted something portable, and I saw this, and I go, oh, that's just so cool. How hard could it be? And it just kind of snowballs from there, and yeah.
My next question is, myself, personally, I look at it as saying, okay, if I need something, I go out and I buy it. I don't necessarily look at something and say, okay, you know what, maybe I can build it. Some of these guys, like you, for example, could go out and build it. Is it more of a challenge, you would say, for doing this, as opposed to just say, go buy something off the rack?
Absolutely, it's a challenge. Because, I mean, what would a 14-inch or a 16-inch mead cost? It would cost you quite a lot, and that's not money I just have kind of kicking around. It would be really hard to sell at home, Whereas I can say, hey, I got this kiln for $100, off of Kijiji. I'm saving money here, and I can go to Flintstone Glass and get my glass for $80. So all of these little things, ultimately they do add up. And frankly, one of the major sticker shockers here. So all of these things are relatively inexpensive, and it's just basically more time, that you're putting in. But there are some sticker shock elements here. Like for example, when you get really fast, you need much larger secondaries. And I'm right at that threshold. Like for mine, I need a 4-inch secondary. But for Mel's 25, he needed I think it's an 8-inch secondary. And there you're talking about like $800-900, like a lot of money, unless you fabricate your own, which is a whole other thing, So you could actually do that too, but that just sort of adds to the time and aspect of it. The other sticker shock is actually coating the mirror. And so again, luckily at around 14 inches, it's still relatively affordable to send it out and get ultra high coatings. It's going to be a couple $100. But Mel, again, he had to pay, I think it was $1,400 to coat his 25. because 25 inches you need much larger equipment to do that sort of thing. So not everyone is set up to do that sort of thing. So in fact, this the group of people that are all sort of my mentors, and we're all kind of helping each other and learning from each other. Some of them are actually experimenting with do it at home silvering again. Which used to be the way it was done, right? Until you could, get your things alumnized. But, but one of the nice things about silver is that it is unless you get ultra high reflective coatings, which are expensive for aluminum, silver has a much higher reflectivity than your stock aluminum. So if you just get an aluminum coating, you're looking at about 87, 89% reflectivity, whereas silver, it's 95, 96, 97% reflectivity. And the only way you can get that with aluminum is to pay for the ultra-high reflectivity coatings. So, but then the downside to silver is that you need to do it over and over and over again because it tarnishes much more quickly. But if you can do it at home for 30, 40 bucks, I'm good with that. So I haven't decided what I'm going to do yet, but I'm considering that too. So,
my final question is: you mentioned it took 19 months to get to the first one, and then another 6 months. What have you been doing stargazing wise since between without a scope?
I mentioned the hockey part, right?
Yes, yes.
There's hockey, and then when there's not hockey, there's select baseball as well. So. Yeah, and I was doing a project alongside this, which was to basically create a new tube assembly for my 8-inch Dob to at least make it collapsible. And so I took apart my Dob, thinking that I would make the new tube assembly and whatnot. It's still apart in a box in my workshop next to where I'm making this mirror. So I confess, not an awful lot. Occasionally, for special occasions, I'll reassemble the Dob because I still have the old tube, for like Venus transit and whatever. So, but Paul,
that fast focal ratio. What about coma?
Okay, so you need a paracore for sure. There's no ifs, ands, or buts about it. You design it with the paracore in mind, and either use the P2. Which basically sticks into your eyepiece. I don't know if people are familiar with what the paracore is. Yeah, so a coma corrector. So you can have the P2 that sticks into your focuser, and then you put your eyepiece into that. But another approach is to use the SIPs, which is another teleview thing, which basically is a paracore integrated right into your focuser. So one reason why you wouldn't want your carry away paracore is if you have multiple telescopes and you want to put it into different scopes. But if you only ever had one, then it makes sense to potentially build it right into your focuser so that it's one less piece to carry around, and basically you just pop your eyepieces in and you're good to go.
I think it's really amazing.
Thank you.
My mind went blank. No, I know, I remember. How many hours would you say have you put into making the mirror? Not on round 2, let's say.
I haven't added up the round 2 numbers, but the round 1 numbers, it was like 19 months in calendar time, and in clock time it was about, I think it was about 200 hours of polishing. So when it comes out of the kiln, while you have the rough shape, and you typically save the hogging step of getting your rough curve, you still have to go through the process of going through the finer and finer grits, and then ultimately the polishing and whatnot. So it's not like it comes out of the kiln and you're into figuring. But even on version 2, I was able to power through that a whole lot more quickly, because in version 1 I was getting just some weird measurements, and it turned out to be that my shape wasn't completely circular. It was actually slightly ovoid, and so depending on which diameter I was measuring the Sagitta on, it was differing by a little bit. And it was only like a millimeter, right, in terms of diameter, but it made a difference in the sag, and it made me crazy trying to figure it out. So I wasted a lot of time there too. But So, but yeah, I haven't added up the clock time on hand to glass on the new one.
And what type of tool would you use before you got into the figuring?
That just a tile tool. So basically, you would cast hydrostone, some kind of something like hydrostone or gypsum or something like that, and you embed just glass tiles, and you cast that against your glass, so that you get the right shape. And then you use that for all of the rough and fine grinding. And then once you're done with the fine grinding and you're into the polishing, then you go right to pitch lap. So that part of it is basically just like standard ATM stuff. So there's nothing magical there with the meniscus. Norm. You know, it's not that bad, because I mean the meniscus is really light, and typically I do it mirror on top, so you know you're moving a very small, relatively light piece of glass. I mean, you know, 14 inches is still, you know, it's like a big piece of glass, but it's only a ½ inch thick, and it's just very light, so it's easy.
Are meniscus mirrors commercially available?
I don't think so. I don't think so. I don't think that there are any. Certainly, none of the major scope manufacturers are doing it.
Any more questions?
I should add that Mel, you know, so he just had his 25-inch coated. His next one is a 42. He's already got it, and he already has it slumped. He already has it slumped. So, you know, but yeah. So they're definitely pushing the boundaries. So I sound like I know what I'm talking about. I'm standing on the shoulders of giants here. You know, I mean, these guys have done all the hard, heavy lifting, and so I'm just trying to do sanity checks, essentially, you know, to see whether it is as easy or as doable, you know, by mere mortals, you know, as opposed to someone like Mel.
I have a question.
Yes.
Did you buy the glass pre-cut, or did you cut it yourself?
I bought it pre-cut, yeah. Yeah. So, but you know, that's easy, because again, you just go to any glass place and you just say, I want a ½ inch piece of glass, plate glass, and they'll cut it for you. You don't want them to chamfer the edge or anything, but make sure it's not the word is escaping me. No, yeah, definitely not chipped. No, tempered, not tempered.
Mm.
I have another question. Where do you send your mirror to get illuminized? What are the options?
There are a lot of options in the States. In Canada, there aren't. The best option, I think, in Canada is in Montreal. A guy called Norman Fulham. The thing about and I would like to go to Norm, and I've corresponded with him, you know, a little bit about this now. But the downside is that Norm doesn't do enhanced coatings. And he feels very strongly about it, and so consequently I have to decide whether, you know, I want to go local but not get an enhanced coating, or my other shortlist name right now is a place called Spectrum Coatings, which apparently a number of people use. They're down in Florida, and for my glass it'll be, I think, $240 for the ultra enhanced 97%.
Place in Sudbury is gone.
Don't know about a place in Sudbury.
He's still there, still in business. He's not doing commercial coatings because it's used after his place burned down a few years ago. So he's still working on all slopes and other optics, but he's not in the commercial business of coatings.
I have an online question here. What is the cool down time for the thin mirror versus the standard?
I've not tried to minimize the cool down time yet, but certainly half hour to an hour kind of thing. Like, you know, if I'm planning on doing a star test, for example, I'll put it outside and then put the kids to bed, and then I'll go out and do my thing. Yeah, and I think that that's relatively typical of what the other guys are seeing too. Now, for for a larger one, I don't have experience with like a really big mass mirror. How long does it take for the DAO one to cool or the CAO one to cool?
You're chasing the temperatures that's dropping all the time. So a really big mirror, let's say you've got an 18-inch.
Mm-hmm.
If you're working with an 18-inch mirror at the CAO and it's sort of a fall evening, you're probably chasing the temperature down all night.
Yeah.
Yeah.
Anyone else? Great. Thank you very much.
Great. Thank you very much, Tom. Absolutely fascinating. And we can tell from the number of questions a lot of interest. And tonight I'll learn about some... I'll learn about some interesting, I guess, terms: hogging, slumping. Well, what else? So when you're in a slump, that's a good thing for you, I suppose, right? All right. All right. Thank you very much to our speakers. We're getting ready for announcements by our president, Ralph Chow.
All right, well, let's take a look at some of the upcoming events. So our next meeting in 2 weeks is a lecture meeting, and we have a speaker from the Physics and Astronomy program at York University, one of the folks that Paul Delaney is taking care of, and his talk is on active galaxies and a hunt to understand what feeds these galactic monsters. So that should be an interesting talk on May 9th. 2 weeks after that is our next Recreational Astronomy night. Do we have somebody set up to do the sky this month?
Not yet, but we're waiting a response.
Ah, okay. So it'll be the very, very famous TBA to be announced. Then we've got Mehdi Bozo-Ray coming back to talk about exploring the Kuiper Belt with New Horizons, and Blake Nancro talking about session planning with SkyTools. SkyTools is one of those software packages that allows you to plan out your observing, and Blake has been doing a lot of work in promoting the use of that kind of tool for planning your observing sessions. Solar observing, we've had a relatively successful astronomy week. We had, what, 2 sessions that were successful, despite all that lousy weather that we had as winter made its final blow. But we've got more solar observing scheduled for this Saturday, and it looks like there's a relatively good chance that we might actually have a good sky for it. So we'll see what happens. Sean's going to do the go, no go on Saturday morning at the latest to let us know whether we can go ahead with that. We also have a couple of our regular monthly sessions going on. For example, Deep Sky, we'll have the next scheduled session for Dark Sky at Long Sault, the first clear night of the 14th, 17th of May. City Star parties, it was too bad about the events on Monday, because that would have been a great night for the City Star party at Bayview Park, but things intervened, so we'll have to hope for maybe a clear sky tomorrow night for the April City Star party at Bayview Village. And then after that, the next one will be 21st to 24th of May, same site. We've got a lot of outreach starting up now because of the return of warm weather. And we've already started with Millennium Square that has been going on. I think we're into the second event there coming up very soon. But in the meantime, we're coming up to also the annual Science Rendezvous. This year's Science Rendezvous has 3 sites that I'm aware of, Ryerson University, York University, and the University of Toronto. And we will be setting up a booth at the St. George campus of the U of T for the 12th of May between 11 a.m. and 4 p.m. Eric Briggs is running that program, and he's got a message on the forum, and he asks that anybody who's interested in volunteering to contact him by email, and he'll let you know what the arrangements are for Science Rendezvous. Millennium Square has its next session on May 18th, and so far it's going fairly well too. They had a successful session last Friday, and again, this is one of our programs that's been very successful, and Arnold Brody is the coordinator. He's right down here at the front. If you're interested in chatting with Arnold about that, he'll be happy to talk with you about the program. We're still looking for some people to help with our electronic communications with Twitter and Facebook. And again, if you can help out with that, we very much appreciate it. I try to avoid them myself, but that doesn't mean everybody else has to. And we do use them quite a lot. Okay, big thing, DDO. You've heard a lot about it over the last few months sporadically. I can tell you that we finally have a draft contract that was sent to the DDO committee and me on Tuesday. So we are looking it over. Hopefully we will have that contract finalized sometime in early May. And if that happens, then we'll be full speed ahead at the DDO. There is a bit of a time limit on this because Richmond Hill has already announced that there's going to be a gala public reopening of the DDO on Saturday, 9th June. And we're expected to be there and smiling. You know, I'm going to use my income tax smile on that occasion. But in any case, we are expected to be up and running as soon as we get that contract finalized. So again, that's something. We are going to need volunteers for this event because they expect it to be a big show. It's going to be an all-day event, and we will have the 74-inch telescope running as well. So lots to do that day. Joel? I'm not allowed to say anything about that yet, but it basically describes what we're expected to do, how the money is going to be split between the center and town of Richmond Hill, and what facilities we're allowed to operate and things like that. And also, you know, what our volunteers are going to have to do in order to be able to participate. So there's a number of things that still have to be done. And again, if any of you is interested in volunteering at the DDO who hasn't already contacted either Ian Wheelband or Bhairavi Shankar about volunteering at the DDO, please see me and I'll pass along your contact information. Because again, we're going to need a number of people to help out with that program. But there's a lot to be done yet. Okay, and as Phil was saying, the Carr Astronomical Observatory, always open for bookings, and again, there's a lot going on there, and it's really exciting to hear what is going on. And you know, that reminds me of the phone call I got 20 years ago in coming September, when Cliff Carr phoned me at my office and said, "I'd like to discuss a little donation with you." Oh, yeah. Anyway, lots of good memories about that. So, again, if you haven't been out there, please think about going up to the CAO. And another benefit that we have is the loan program. We've got lots of hardware available to loan to try out. And again, we encourage people to participate. And we have our program manager, Peter Richards, up in the back. Right, and we have some of the hardware out front in the foyer that you can take a look at as well. So again, it's there for the use. And finally, meeting after the meeting at the Granite Brew Pub after we finish here tonight, and hopefully we'll see a few of you there. Ron McNaughton, what can I get?
I watched the European Cup soccer game this afternoon, and every time I've gone, I've taken my ticket with me into the bar, but they just give me a token. There's a new policy that you have to hand a ticket when you enter the parking area to get a token. So just bring your ticket.
Okay, so again, just a message about parking access at the Granite Brew Pub. I guess they want to really control the parking. So again, you're warned. Yes, Chris Vaughn.
Two things. First of all, I'd like to thank Andrew and Betty for the fantastic photos taken on the site.
Yeah. Thank you to Andrew and Betty Reed for the photographs they took at the Astronomy Day program. And
second of all, I attended the planning meeting for June 9th open house at DDO on Monday. It's from 1 to 4 p.m.
Ah, okay.
We'll be doing solar observing, we'll be doing some Ask the Astronomer, we'll be doing some guided tours, and we'll send details out.
Okay, great. Thank you. Okay, so for those online who may not have heard, Chris was just saying that the DDO open house program will be 1 to 4 p.m. on June 9th, and we'll be doing solar observing, meet the astronomer, and tours. So that's it for tonight. We'll see you again in 2 weeks. Be safe going home. We'll see you at the next meeting. Okay. All right. Good night, all.